Each of 5 through 21, prove each statement that is true and find a counterexample for each statement that is false. Assume all sets are subsets of a universal set U. For all sets A, B, and C, A minus B minus C equals A minus B minus C. And we can do the same thing that we did in the last video where we drew both of these with a Venn diagram separately and compared the results. Now we'll start with the left-hand side. B minus C is this region over here. But then A minus B minus C is what we get when we highlight A and we remove B minus C, which would be everything in A that's not in this blue region. And that is A minus B minus C. Now let's go to A minus B minus C. A minus B is everything in A that's not in B. And then we have to imagine removing C from this set. Well, the only part that's in C is this part right here. So the only part that would be remaining is everything that's in A, that's not in B and is not in C. And that would be this region here. Now let's compare the differences between the two. I'm noticing that the left side has elements in both A and C, whereas the other side does not have elements in A and C. So we just need to create sets A, B, and C where A and C have elements in common. So I'll let A equal 1, 2. B is going to be 3, 4. Those don't really matter, but C is going to share some elements in common with A. So I'll have this be 2 and 5, let's say. Doesn't really matter what that second element is. Usually this strategy works. So now let's evaluate the left-hand side and the right-hand side separately here. First, we'll do B minus C because according to PEMDAS, we should do parentheses first. B minus C is everything in B that's not in C, which is just everything in B. And A minus B minus C is everything in A that's not in B minus C, which is just everything in A. Now we can compute the right-hand side separately, starting with A minus B. A minus B is everything in A that's not in B, which is just everything in A. And then we have to take that set and subtract C from that, which means we have to take 1, 2 and remove everything in C, which is just 1. And lo and behold, we have produced different results with these sets, meaning the left-hand side is not equal to the right-hand side because these two sets are not the same sets. And that's because we designed A and C in such a way that includes an element that is in both sets. Therefore, we have provided a counterexample to show that this statement is false. Thanks, everyone, and I'll see you in the next video.